Most senior engineers fail system design interviews not because they don't know architecture, but because they don't explain trade-offs, failure modes, and business impact. In this video, I will cover advanced system design questions that are asked at staff, principal, and engineering manager levels, and how interviewers actually expect you to answer them. Question 1. How do you prevent hotspots in a distributed system? Hotspots occur when one server, shard, or server gets disproportionate traffic, causing performance issues. To prevent them, use consistent hashing to evenly distribute requests and keys across nodes. Introduce randomization or load-over partitioning for skewed workloads, and add caching layers to reduce repeated database hits. For write-heavy workloads, batch writes or queue operations to smooth traffic spikes. Additionally, continuously monitor traffic patterns and automatically redistribute load if one node starts receiving too much. Design your system to gracefully handle uneven load so a single hotspot doesn't impact overall performance. Interview tip. As an engineering manager or senior engineer, don't just explain how to prevent hotspots. Explain how you would detect them early, assign ownership, and guide the team to fix them safely in production. Question 2. How do you design a system to handle millions of requests per second? To handle millions of requests per second, you need to think in layers. Start with stateless application servers and horizontal scaling, so you can add more instances as traffic grows. Use a load balancer to distribute requests evenly and cache frequently accessed data to reduce database load. Databases need sharding or partitioning to prevent bottlenecks, and asynchronous systems like message queues help smooth certain spikes. Implement rate limiting and throttling for heavy users. Observability is key. Monitor latency, throughput, error rates, and server utilization in real time to detect hotspots or bottlenecks. Finally, plan for scaling across multiple regions if global traffic is expected. Interview tip for this one. Always discuss trade-offs. Scaling horizontally increases reliability, but also operational cost. Caching improves speed, but may serve stale data. Show your reason about performance, cost, and complexity together. Question 3. What strategies would you use to handle cascading failures in microservices? Cascading failure occurs when one failing service causes others to fail, which can bring down an entire system. To prevent this, implement circuit breakers. To stop requests to failing services and allow them to recover. Use timeouts and retries with exponential backoff to avoid overwhelming dependencies services. Introduce bulkhead to isolate failures, so one service or group of requests doesn't affect others. Asynchronous communications via queues or event-driven patterns can decouple services and reduce dependency. Combine this with strong monitoring, alerts, and automated remediation, so failures are detected quickly and mitigated before spreading. Interview tip. Observability is as important as architecture. Show how you detect, isolate, and recover from failures in production. Question 4. How do you design for high availability in a multi-region system? High availability requires replications of services and data across multiple regions. You can use active-active replication so both regions handle traffic simultaneously and failover instantly if one goes down. Implement health checks and automated failover for services and databases. Cross-region latency is a consideration. Sometimes eventual consistency is acceptable for certain operations. Include redundancy at every layer. Multiple load balancers, multiple application servers, and database replicas. Lastly, test your failover plan regularly using chaos testing or disaster simulations to ensure your system recovers gracefully from outages. Interview tip. Talk about testing for failures. Systems aren't just designed, they need verification under viewable failure conditions. Question 5. How do you decide between monolith versus microservices for a growing product? Start with a modular monolith for simplicity and fast development. Microservices are ideal when services have independent scalability, deployment, or ownership needs, but they introduce additional complexity. Network communication, monitoring, deployments, and distributed data management. Consider team size. Smaller teams may struggle with microservices. Also evaluate business priorities, speed of feature delivery versus long-term maintainability. The best approach is incremental evolution. Design modules within the monolith so splitting them into microservices in the future is straightforward. Interview tip. Focus on trade-offs, not absolutes. Interviewers want to see reasoning about simplicity versus scalability versus operational cost. Question 6. How do you handle data consistency across distributed services? Distributed systems rarely allow perfect consistency without trade-offs. Strong consistency can increase latency, while eventual consistency may lead to temporary divergence. Use a single source of truth for critical operations. Distributed transactions like two-phase commit when strict correctness is required, or event-driven approaches with idempotent consumer to reconcile data asynchronously. Always document the consistency model for each service and define acceptable state. Staleness based on business requirement. Combine this with monitoring to detect anomalies early. Interpreting. Always state your assumptions about consistency, latency, and business requirements. Question 7. How do you design a data pipeline for real-time analytics? Stream data from sources using platforms like Kafka or Kinesis. Process it with stream processors such as Flink or Spark Streaming to compute metrics in real time. Store results in Queen-optimized stores like NoSQL or OLAP databases. Handle backtracer, ensure idempotent pass processing, and use checkpointing to prevent data loss. Include monitoring for throughput, lag, and errors, and consider scaling the pipeline horizontally to handle spikes. The key is designing a reliable, fault-tolerant, and observable system that can process high-velocity streamings without losing data. Interpreting. Reliability and correctness are more important than raw speed. Emphasize that in your design. Question 8. How do you ensure data integrity in distributed storage system? Data integrity requires application, versioning, and consistency checks. Quorum, base, writes, and reads prevent stale data from being served. Implement checksums and reconciliation jobs to detect corruption or divergence. Plan for network partitions and failover scenarios, defining acceptable consistency levels for each use case. Monitoring and alerts help detect anomalies, and regular automated audits ensure long-term correctness. This ensures that distributed systems remain reliable even under heavy load or network failures. Interpreted. Discuss gap trade-offs, consistency, availability, and latency. Show practical understanding. Question 9. How do you design a secure system at scale? Security requires defense in depth. Anchor data at rest and in transit, enforce role-based access control, and segment the network to isolate critical components, including auditing, monitoring, and anomaly detection for suspicious activity. Automate security checks in CI/CD pipeline and regularly patch dependencies. Consider trade-offs, encryption at latency, RBAC, adds complexity, but these are necessary for safe scaling. Finally, integrate security into architecture reviews so it's protective, not reactive. Interpretive. Balance security with usability and performance. Interviews want practical solutions, not just theory. Question 10. How would you balance speed of delivery versus system scalability and reliability? Balancing speed and reliability starts with prioritization. For early features, focus on delivering value quickly using modular code and feature flags. Monitor systems behavior and use alerts to catch issues early as the system grows. Invest in scalable architecture, automated testing, and observability. Evaluate business impact. If downtime is tolerable, speed may take precedence. If it's critical, reliability comes first. Encourage the team to document assumptions and trade-offs, and revisit decisions as requirements evolve. The key is making strategic, data-driven decisions rather than purely technical ones. Interpreted. Justify trade-offs clearly. Showing strategic thinking is as important as technical correctness. At senior levels, system design interviews aren't about knowing more technologies. They are about making better decisions. Every strong system design answer should clearly cover three things: scale, failure scenarios, and trade-offs. If you can explain those well, you are already ahead of most candidates, because system design interviews aren't about building the perfect architecture. They are about showing you can make the right trade-offs under uncertainty. If you found this video helpful, please like the video and subscribe for more system design and engineering interview content.